Welcome to question 2 of the 2020 TMUA Paper 1. The question tells us that 2x plus 1 and x minus 2 are factors of 2x cubed plus px squared plus q. It asks us to use this information in order to find the value of 2p plus q, and we have 6 options listed. Pause the video, read through these options and have a go answering the question for yourself. Okay, well, what do factors of a polynomial tell us? Well, each factor gives us a root or a solution of this polynomial if we set it equal to 0. So the factor x minus 2 tells us that 2 is a root of this polynomial. So if we plug 2 in here for x, then this expression will equal 0. But what about the factor 2x plus 1? Well, we can rewrite this as 2 times x minus a half. And therefore this tells us that x minus a half is a factor of this polynomial, and therefore minus a half is also a root. So by the factor theorem, minus a half and 2 are solutions to this equation. So now we need to use this information in order to find the value of 2p plus q, and in fact in order to do that we're going to need to find p and q. So pause the video and have a go at doing this for yourself. Indeed, let's start by using the fact that minus a half is a solution to this equation, and let's sub in x equals minus a half. So that gives us this equation. And now if we expand these brackets, minus a half cubed is minus an eighth, and minus a half squared is a quarter. So when we multiply the minus eighth by 2, we get minus a quarter, and then a quarter p, and just q. And now let's multiply this through by 4 in order to get it in a slightly nicer form, which is minus 1 plus p plus 4q equals 0. And we're going to call this equation 1. And now similarly, we can sub in x equals 2 into this equation to find that this equation must be true. And again, if we expand these brackets, we find this equation, 16 plus 4p plus q equals 0, and we'll label this as equation 2. So we now have 2 simultaneous equations for our 2 unknowns p and q, so we can use these equations in order to solve for p and q and then find the value of 2p plus q. So let's begin by eliminating one of our variables by adding these equations together in a clever way. So how can we do that? Well, we have a coefficient of 4p in equation 2 and just 1p in equation 1. So if we subtract 4 times equation 1 from equation 2, we will eliminate the p's. So let's do that. And 16 minus 4 times by minus 1 gives us 20. And q minus 4 times 4q gives us q minus 16q, which gives us minus 15q. And on the right-hand side, we just have 0 minus 0. So we reach this equation, and therefore if we move the 15q to the other side and divide through by 15, we see that q is equal to 20 over 15, which we can simplify to being 4/3. Okay, so how can we now find p? Well, if we substitute in q is 4/3 into equation 1, then we see that we have minus 1 plus p plus 16/3 equals 0. And if we bring the minus 1 and the 16/3 together and move them onto the other side of the equation, we see that that tells us that p is equal to minus 13 over 3. So we've now solved for p and q, but what did the question ask us to do? Well, it asked us to find the value of 2p plus q, so we can therefore substitute in our values of p and q and see that this is equal to minus 26 plus 4 divided by 3, which is just minus 22 over 3. So if we look back at our options, that is exactly option C. So we can therefore conclude that the answer to the question is C.